All right, let's see. Hopefully the audio isn't completely gone. Oh, here goes Moshley. Testing 1, 2, 3.
Hey, Aaron.
Hey, Mosh.
You getting better now?
Yeah, I'm good.
Okay.
Why do you keep going through the side door?
Side door's locked now
Yeah, but why do you keep going through it?
because it's like another way to enter, so I don't have to like walk around to the back.
Okay.
But someone must have locked it from the inside.
Where are you coming from?
My apartment. I went back to get my car as always because I
Isn't
take
it
the shuttle since I have class in the morning.
Isn't it faster just to go through the back?
Kind of. It's like a shortcut here.
Okay.
If you ask it. I need to meet up with my 138 professor, so I might be,
Leaving.
yeah, I'll leave my stuff here because I have a group for 133 now, and they're gonna be meeting here.
In here?
Yeah, maybe we'll move to another location and
Because
talk
it-
about it elsewhere, but,
There's probably going to be another group coming in here after us.
oh, okay.
So I don't think this is going to be a maybe place you guys are going to be able to
It's only gonna be like 3 to 60 minutes.
All right.
Yeah.
Yeah, because these rooms are jam-packed from one to the next. So,
I see. But I'll leave my stuff here so that way,
okay.
in case of anything.
Go for it.
Is Michael coming?
No, Michael is dealing with something right now, so he's not going to be coming. Why am I not getting audio?
So you're gonna be the sole host for today?
I am running everything. That would be correct.
Gotcha. Yeah, anyways, I'm gonna go meet with Professor Tran right now because his hours got cut short. It's now 2:30 to 4 instead of 3 to 4:30 because he has a meeting at 4.
Okay.
Anyways, I will be back in a moment, alright? I'll
Alright.
see you in a bit.
See you in a bit, Mosh.
Okay.
I want to see what that's. Hey, Mosh. Mosh. Moshley. Moshley.
Yeah? Oh, I'm sorry. Am I in your way?
No, I can hear your music.
What?
Yeah. You're gonna get us a copyright strike, my guy.
That's impossible.
No.
I have AirPods on.
You weren't playing through your AirPods, you were playing through your speakers.
What the heck?
Okay.
Well, I think it didn't play. I guess it might have not connected until a minute later because it obviously says, look below.
Well, I know what it says now, but earlier it did not say that.
Oh, yeah, sorry. I thought
Don't worry about it, Mosh.
I was about to play music on my way to the thing.
That's fine.
Yeah.
But like again, remember, we do live stream it to YouTube, and YouTube is not very forgiving if it catches any audio being played.
Yeah. Even if it was a mistake on my part.
Yeah.
Because the AirPods-
Again, YouTube is not forgiving.
Because the AirPods did not connect properly.
It does not care.
Oh.
My sister was playing Eminem in 2 rooms over, and the microphone picked it up. I had 2 channels get taken down that way.
Oh.
YouTube
Man.
does not care.
My goodness. And now guess what? They're starting to become jerks because they started to crack down on ad blockers now.
I mean, they've been saying they've been going to do that for years, so that's not really surprising.
Yeah, because I keep getting these messages saying ad blockers not allowed, your playback will be blocked after free videos.
Yeah.
So I had to disable it, or else my YouTube gets messed up.
Yeah. I mean, again, that was expected. They said that they were going to be doing that, so. All right.
Anyways, I'll see you in a bit.
See you in a bit, Mosh.
All right.
I hope some people are going to come today. At this point, I'm not holding my breath. I wonder if people read Michael's message and thought we weren't having a meeting today.
It just means more Subway for me.
Means more what?
More Subway for me.
I did order Subway for today, so I don't know where it's at.
Why didn't we have the cookies that one day?
I wanted cookies. I wanted to try all the cookies, and it was the cheapest method for me to eat all the cookies.
Yeah, that was my first time trying the cookies too. And I'm like, wow, that was actually pretty good.
Yeah, no, they have a lot of good cookies, and unfortunately, it's like another $50. But you know what? I thought it was worth it. It was worth the club buying $50 worth of cookies. Let me check some stuff out real quick. What am I doing? I'm going to YouTube. Going to my channel. I'm going to go to our live video. I mean, if not, I have something I could show off. I was planning to do a paper airplane competition. I have all these paper here. Drew!
It's a big meeting today.
Yeah, I think Michael's message may have made people think that we have no one today. So.
Oh, there's another.
Oh, wow, more people. Perfect. I was getting worried. I'm just going to create an event real quick.
Can you watch my stuff really fast? I'll be right
Yeah,
back.
go for it. I think the Subway forgot that they were supposed to deliver food to us. If anyone is the time to just run over there and be like, hey, can I grab the food for the data science club? That'd be pretty cool.
It's just the one.
Yeah, the one down there.
I guess.
You gonna get it for us? Thank you.
So what do I do if they don't trust me?
I mean, who's gonna go down there? It's like, hey, can I get the data science food?
I don't know.
Yeah, hold on, do you want to bring the receipt with you just in case?
Okay.
It'd probably be the best idea.
Yeah.
Don't copy my credit card number off it. Which receipt is it? So today is November 2nd, right? This is October, there's 9, there's 2. I'll take that with you. Please bring that back, dude. Don't lose it. All right, how's everyone doing? All good? All good. All right, so the event planned for today was planned for a little more people than 5. I brought paper, and the plan was to do like a paper airplane contest or a introduction to machine vision. I was gonna let people decide, but at this point I might do both. But let me set this up real quick first. What do you guys know about machine vision? Not at all? Okay. Machine vision is actually pretty cool. It's incredibly slow and horribly unoptimized. When you think of just vision in general, you think, oh, hey, I can see something. It's going to be like right there in front of me. And I can identify that. Well, obviously, machines don't have that ability. All they have is the camera array, so it's just the array of pixels everywhere. And in that array of pixels, it doesn't really know it's there. And so what we do is, actually, let me finish setting this up first before I give this entire speech and actually pull up the slides, because that's probably the best idea moving forward. And I think we can spare 5 minutes. But in the meantime, if anyone wants to make a paper airplane, go at it. Supposedly next week we're also going to be having a speaker from Google, potentially. We're still trying to figure out what's going on with that. And if so, I'll let you guys know. And hopefully that'll be pretty good. How you doing, Drew?
Sort of hanging in there. It feels like everything's been
Chaos.
chaos and assignment after assignment since midterms. My professors have no chill. So, it's just been constantly struggling to catch up. I have a big programming assignment that I need to do tomorrow.
That sounds not
and
fun.
It involves port scanning.
Boards? What class is this for?
Network fundamentals.
One
So,
38?
You on 38, yeah. Have you taken that? Oh, yeah, of course you have. You're about
Yeah,
to
yeah.
take off, yeah.
Hopefully I would have taken it by now.
Yeah. I don't know. Can't you save it for your last semester?
Technically, you can do everything in your last semester if you're crazy enough. Hello.
Hi.
What's your name?
My name's Allie.
Nice to meet you, Allie. I'm Aaron. Pardon me as I frantically set everything up, thinking that I had enough time to do all of this, and apparently I did not. Because I am anything if not a very last-minute person. Just need to make sure I can set this up so that we can get reimbursed. Well, let me repeat that. So I can get reimbursement for all the food that we are supposed to get here in a minute. And hopefully, cannot remember that guy's name, will get back to us with that. I'll eventually remember everyone's name, that or I'll leave and I won't have to memorize anyone's names. While we're at that, what's your name?
Julian.
Julian, Omar, you just told me it and I should know it.
It's Allie.
Allie. What's your name in the back? Ronan? Ronan. That's a cool name. Ronan and of course Drew here in the front. And Mosley, who stepped out. I think his name is Alex. I'm gonna go with Alex for now.
I think it's Drew, but I don't remember his name.
Yeah.
I don't think we should really introduce ourselves, I think.
Yeah, and in hindsight, when we had more people, we should have done like a group game, but I didn't really think about that because I was kind of just thinking, all right, how am I going to plan lessons out for the next part of the semester? Because we were supposed to do the drone project and we were supposed to be teaching people for that. And then Hashem decided to pick up another class during the meeting time. And so that just went to... By the way, tomorrow we're supposed to have like a showcase for the drone, or what we have of it. We have a vision system, so we have an Intel depth sensing camera. So basically, does anyone know how Face ID works effectively? It's like a LiDAR sensor, so it just shines a ton of squares on your face, and depending on how the size of the square, it knows the distance.
Oh, that's cool.
Yeah, right? It's really cool geometry. But effectively, we have a camera like that from Intel that can shine those squares roughly 25 feet away. After 25 feet, all the squares are the same size, so it doesn't really matter. We have a Intel, sorry, not an Intel, an NVIDIA, not a Newton, I think a Jetson Nano. We have a NVIDIA Jetson Nano for the brain of the computer, so we're going to be using that to do object detection. We also have some other drone parts, some servos and whatnot to make it fly. So fun stuff. So it is moving in the background, but the plan for it to be moving in the foreground with, you know, giving a lecture every single week to get you guys up to speed of like how to build a drone and how to like make it learn and stuff, clearly didn't happen. I do apologize for that, but what am I going to do? I'm only one person. I can't run a club by myself. Though everyone seems to think I can, which is awesome.
I have faith in you.
Thank you. I've successfully run this club for 2 years with little hitches, so I think we're good. Anyways, so let's go over here to my projection. 2 truths and 1 lie, that is not correct. That slide was supposed to be disappeared a long time ago. Since we do have food coming, would people mind signing in so that we can get the food reimbursement? So if everyone could scan the QR code, that'd be great. In the meantime, what am I doing? I am grabbing my slides. Okay, so what? Oh, shit. Cool. So this is some homework I did for machine vision in the Triple E course. Why there's machine vision in Triple E and not in computer science is beyond me, but that is the department that machine vision is taught in. And so I decided as a little computer science student to go take electrical engineering courses. And it was really fun, honestly. I got to learn quite a bit about how machines see. I did better than almost all the engineers in the class, which was awesome. The professor was not happy that the one computer science student in his class was doing better than all his engineers, especially all the master's students. So it was fun to be the little special kid in class. And so, oh, this is a fun one. So this is an example of how a machine can identify an object. The very, of course, simple way to identify an object in an image is to know what the object is going to relatively look like, and then scan the entire image and basically match the image, the smaller object image, to the rest of the big image. Pretty straightforward, pretty simple. And as you could probably guess, that takes a very long time. It's also pretty dumb simple. And I was actually surprised that was just how we did things for a while. Give me a second. When you think of like identifying objects, you don't necessarily think, oh, I'm just going to have the object already and just scan the entire image to look for it. But that's just really how it works. It's not very complicated. It's extraordinarily simple. It's in MATLAB. You know, very simple, very straight to the point. Is that mine or yours? Gotcha. Yes. 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 Cool.
Oh, I hate the phone.
Yeah. It's ugly when you look at it. It is completely simple. It is literally just food. Let's go.
Gross.
Hey, Colton.
Your horse is mouthful. Nice to see you again.
I see you smelled food and came to the meeting.
I was walking with him, okay.
Okay.
In the last 2 minutes. So I was technically a part of this project. I will be putting this on my resume.
All right.
I was moral support,
Of course.
which the morals were very much supported, as a moralized computer scientist can be.
Morals in this college are very interesting for CS.
What are those?
Thank you so much. So this is how a computer sees, actually. You're in front of the camera.
It's a picture.
Oh, so the original plan was if we had enough people, we'd be making paper airplanes and doing like a paper airplane contest. Clearly, we have 7 people, so plenty of people to do an airplane contest. Not anymore, so we're doing a little intro lecture to how machines can see.
With their eyes.
Yes, but how?
Well, am I the one who's doing this? I'm just the one who's copy and pasting.
You want to take a seat and learn and grab some food while you're at it? Your name is Alex, right?
Oh, I'm Matt.
Matt. Wow, I was so off. Wait, so who's Alex? What's your Discord name? I should definitely not be showing that.
It's M. Morello.
M. Morello. Wait, you're also M. Morello as well as Moshley? That's wild.
2 people in one?
Yeah.
It's Moshley?
Oh yeah, Moshley Marcello.
Oh. I do actually have to let you know. I'm going to be heading on out in a second. Right.
All right, go grab her sandwich on your way out.
Oh, my heart grows 2 times bigger for you, my friend.
Just get out of here.
Say it as it is.
So how do I exit this? It's been so long since I've used MATLAB. I've been using it on the website. MATLAB has an online interpreter, which is really nice. Let me see if I can just find the report real quick. One would think that when you're doing an impromptu lecture, you'd have everything written out and already set aside. Not like just on the fly going for everything, but basically all it does is the first thing you do in identifying objects in a computer is you turn the image black and white. The reason why we do it in black and white is because it's quite frankly simpler to do everything in one color. Bye, Colton. Love you. Than doing everything in 3 colors, because if you do it in 3 colors, that's 3 times the processing. That's a lot of time. We don't got time for that. So first thing we do, input our image. Again, put it to grayscale, and then we give it the object we want to find. In this case, we're trying to find this person's hand. Now, this person is Professor Neil Levine. He is a robotics professor here, and he's the one helping us out with the drone. We give the program the hand, and then we have it go and find the hand. In this version, we're doing a fast Fourier transform. Does anyone know what a fast Fourier transform is? Kinda, sorta, okay. It's relatively more, kind of an advanced topic. Effectively, what you do is that you take in an input, and then you have effectively a cosine hash, in a sense. It goes through a cosine and sine hash, and it spits out a value between 1 and imaginary 1. Yeah.
3 Blue, 1 Brown had an amazing video on this topic.
Yeah, 3 Blue, 1 Brown does amazing work, and they did. I think it was it for earthquakes or for nukes? I think that one was for.
No, it's just a Fourier
Oh,
transform.
just straight Fourier
There's a lot
transform.
of different applications. It's used
Yeah.
in audio quite a bit.
Yeah, no, Fourier transform is like basically the natural function of the world. It's amazing. But yeah, it goes from 1 to, it goes from negative imaginary to imaginary, and in between that is 0 and 1.
What it does is it takes information that exists in, amplitude time,
Mhm.
and transforms it into frequency time.
Yeah, exactly. So it takes it from an amplitude to frequency, or in the case of this one, it takes it and hashes it to a cosine value. Same thing. Obviously, when you have impossible numbers, imaginary numbers, it's not going to look very much like an image anymore. It looks very, very fuzzy. But the thing is, inside here, there is a spot that is brighter than everything else. Effectively, the thing that is closer to imaginary than negative imaginary. Everything black is closer to negative imaginary. Everything closer to white is closer to imaginary. And the one that is the closest is this white spot that's right over here. Now, if we go back to the image where the hand is, the white spot is relatively in the same position of. Do I have? How did that happen? Wait. What?
I think it's your time alert, 'cause
It
it's
usually
3
says-
o'clock right now.
Yeah.
Oh, that was 3 o'clock?
But all we got was the clock. So it's,
I didn't hear that. Did you hear 3 o'clock?
all I heard was it jam its clock in the middle of you talking. So
I didn't hear that. I heard something completely different. If it said 3 o'clock, that's so much better than what I thought it said. I thought it, I'm not going to say what I thought it said. But anyways, we have this super bright white spot right here. I don't know how you guys can see that. But that gives us an indication that our program thinks that at that particular spot, there is the object we're looking for. And then after we do the Fourier transform, oh wait, I got it backwards, sorry. This is the Fourier transform of the image. This is the Fourier transfer of the hand.
Now we put the hand and we try to match it over the image, the spot where it thinks it is, huge white glob, and then we have it identified. Pretty good. Like, it got it almost exactly where we need it to be. And I could do this with any image. The problem is I think it's going to be pretty slow. That's not the right folder. It might be pretty slow. So let me see if I can pull this up, if I can remember which one of these it is. This is the only machine learning thing on here. The problem is this is not the right file. So I'm really perplexed as to why this file maybe it's this one? Kernel mask. That's not right. That's not right either. I'm in the wrong folder, that's why. Is this it? That's still not. What in the world? I am very confused right now. Copy a Fourier example. This is definitely the right folder, so why is the thing different? I am so confused. I think I lost my code. That's unfortunate, because this is actually a really fun program just to show off people like how this all works. Give me like 2 more seconds to figure this out, and if I can't do it, oh well. How do I spell Fourier? When in doubt, copy it out. What in the world? That's so weird. Okay, well, unfortunately, actually, you know what? Copy. New script for yay, because I'm not going to spell it right.
It's Fourier.
Fourier. Oh, didn't like the way I did that? Okay, well, that's okay. Fourier.
Yeah.
Let's do that. That's close enough. Let's clean up this code a little bit. This image that for... I just really want to run this real quick, and I apologize for wasting everyone's time, but this... I'm on a mission to show that this is actually working real quick. By the power of Macintosh, I'm going to split this image. Offset goes to 5. Figure of F. Off gray hand. Figure warning. Display complex. That's good. Show hand. Figure hand width. I don't think is anywhere. I don't see it anywhere. No, yeah, there's nothing in between. Oh, width is the image. It actually gives text value to images. That's awesome. Warning is complex. This image has, it's clearly not part of the code. Hand-bound access. Perfect. All right, so I'm going to use the image that we got a few weeks ago of my beautiful face for ChatGPT, because I'm not going to give it another image. Let's see, I'm going to go to large, and I'm looking for the beautiful face that there I am. Drag and drop this into here. Beautiful. And then we also need...
Oh my god, organization.
Oh no, it's actually... This is the actual organization.
Okay.
I was just looking at the thumbnails. Don't worry, it's not that bad. I'm going to copy paste it real quick. We are going to go into Photoshop. We're going to create a very smaller version of this. We're going to find my face. Now, obviously this version only works with what you already have, and that's not quite good if you want to look for things such as other people's faces that you don't know. And the way that we actually go about finding other people's faces is that we use something called convolution. Has anyone heard of convolution before? That's perfectly fine. Convolution is a mathematics term where we take an array, a 2x2 array, so a matrix, and then we we effectively filter over it. And what a filter is effectively, it's a function. So do you guys know what a lambda function is? Okay, you guys will learn. Are you all computer scientists? Okay, you guys will learn lambda functions eventually.
This function.
Yeah, effectively it's a short function.
It's a one-line function.
Yeah, it's a one-line function. And in mathematics, it's just a really short function. And what you do with that is that you give it to the convolution, and for every pixel of that 2x2 image, it will sample the image or the pixels around that pixel, and then it will overwrite that pixel with a new value. It's really useful for things like image validation, things like what we're doing here with Fourier transform. I think this is the correct one. Yeah. Don't save. And if I did this correctly, beautiful.
That's intimidating.
So let's go ahead and copy this into the vacation image. And then we need to save. We're going to do Fourier because I don't know how to spell. We'll replace
It's Fourier. Like if something's Fourier, you just up it. You just make it a little more Fourier. A little Fourier.
Just make it a little Fourier. Okay, didn't like that, so we're going to do boobop. Because hopefully that'll work. Perfect, it like boobop. Now hope the index bounds cannot exceed 2,000. Let's see. Oh, so my bounds are too low. Let's say 2,000. I don't know, it doesn't matter. 2,800. You like that better? No, it doesn't. Oh, I actually have to know the size of the image? Okay, well, I'm not doing that much work. I just take my word for it. That's how the image works. Anyways, going back to convolution. Let me see if I can find an example of convolution real quick, because showing you guys would be much easier than me going through and... Oh, this is actually a cool one. So this is me targeting the moon. I'll show this to a second once I find the convolution example. Convolution. Beautiful. So this is convolution, a very bad example of it. But here we have the original image of a skeleton. Using convolution, we can do things such as brighten the image. When you go into your phone and you go into the filters to either increase the saturation of your image, to increase the brightness, or to decrease the brightness, or anything in between, you're using convolution to do that. And as Drew said earlier, for loops, convolution just literally goes image or pixel by pixel, and it is slowly going through every pixel and rewriting the data. It is very slow, and this is how we've been doing images for a very long time. The way we speed this up is we just use a physical array. So in Tesla Copilot, it has hardware that is a physical matrix that is the same size of the image from the camera. And so instead of having a CPU software going one by one through each individual pixel, it has one matrix and then has the result matrix, and it has the result matrix sampling from the original matrix. So everything's always on read. And doing this, it allows it to quickly go through and obviously, since it's moving very quickly, it can go through and sample the image much faster than you could ever possibly do by doing it by hand. are obviously doing it by software because, for loops, or hopefully you know that for loops are very, very slow, especially if you're doing one after the other. Oh, perfect. This is a perfect example. So this is what convolution does. Say we have some noise in an image and we want to clean it up. How do we know where the noise is? Well, for one, hello, there we go. For one, we could do a analysis of where there's a difference between the left and right pixel. Obviously, if there's noise, the pixel on the left will have a different color than the pixel on the right. If the image is less noisy, we're going to have less bumps here, or less color change from the left and right pixel. The benefit of convolution is that we can find noise and that we can actually smooth it out. The second benefit to this is that we can find lines. Obviously, this is a zebra pattern. Again, a computer doesn't know the difference between a line and just a regular pixel. And so what we can do is that we can define the lines here. The brighter the pixel, the higher probability that that is a line. And effectively, this is what the convolution is doing. Sampling all the... I'm doing a horrible job of explaining this. But
it's hard to explain.
Yeah.
The computer can only see
so much
values
Yeah.
in a square.
Yeah,
And so what
effectively.
you do to decide if there's like an edge or something like that is you see how rapidly the pixels on one end of the square change compared to the other.
Yeah, exactly. And it's... I'm trying to squish an entire semester down into one go, but effectively what we're doing is that instead of going through and using stuff like...
It's similar to how Gaussian blur works.
Yeah, no, it is Gaussian blur.
It is Gaussian
Yeah.
blur, but it's, if you've ever wondered how like Photoshop would blur images, that's it. It's taking pixel data from all surrounding pixels and averaging the RGB values basically. But then
Yeah.
this is just black and white, so you don't need RGB, just like a darkness value or a lightness value or something like that.
Yeah. Actually, it's a great example is Gaussian blur. Does anyone know the concept Gaussian blur in like an image format? Or just how blurring works in general, how it averages the pixels. So think about how one pixel can get blurred, right? It knows what that value is, but it doesn't know what the values around it is, so it will take the pixels surrounding it and then kind of merge them all together to make it appear blurrier. That's exactly what convolution is doing. It's sampling all the images and giving it and assigning the current pixel a value depending on the images around it.
The pixels around it, yeah.
Yeah, and doing this, we can actually get a pretty good outline of something like the zebra. Here, we took the black and white version of the zebra. Again, we don't really need to worry about all the other colors, but we can clearly see the outline of the zebra here. And this is actually how we do stuff like recognition. We know we have a ton of these images. We know that anything that looks similar to this is going to be a zebra. So if we take a ton of pictures of zebras, turn them into this image, and then compare this with our existing image, so let's say this is our existing image, if they're a match, say around 80%, we can identify this as a zebra nose. That's how your phone is identifying, like if you take a photo of a dog, if you guys have iPhones, I'm not quite sure how it works on Android, and you go into the Photos app, if you tap on the dog, it will know that it's a dog, and it can sometimes tell you what breed it is. Yeah, Drew?
Something I never understood. If you take a picture of a zebra,
Mhm.
process it in a way that you end up with one of these imprints,
Yeah.
basically. By the way, this is another effect that's already in Photoshop. It's, I think, the emboss effect.
Yeah,
That's
embossing,
how
yeah.
But you take that picture, you get this information after all this processing, and it uses this as a data point to kind of guesstimate what the picture is of. If I feed the database that same picture but zoomed out a little bit, how is it going to? I never really understood how it lines things up. Like, does it take this general pattern and resize it and try it in different
Yeah,
locations?
effectively you would add another loop and effectively have it cycle between the largest version of the image and crop all the way down to the smallest.
Oh, I see. That's what's going
Yeah.
on there. It's taking the image, resizing it, and trying it.
Yes, yeah.
That sounds expensive.
Yeah, it's very expensive.
Yeah.
Identification in computers is horribly expensive. And so that's why I was saying earlier, identifying in computers is bad. There's a reason why we weren't able to have stuff like smart cars and AI generation and AI imaging until very fucking recently.
Necessary
Because,
processing power is just
yeah,
monstrous.
the processing power is so much. It takes so much time to get one of these images to work properly. I ran one of my images from earlier, so if we just rerun this image, the original one, because that actually worked properly. Oh, nope, I'd want that to be gone.
It just took hella time. to
It
process.
takes a hot minute, so I can actually run this in the background.
That might be done by the time the meeting's over.
Possibly. No, it'll definitely be done a lot sooner than that, but
See, this is the hang up that I got into when I was trying to design a bot to automatically do dungeons and WoW.
yeah, no, it takes a hot minute. You need a pretty decently powered graphics card to do this.
Do you dip into GLSL programming at all?
I personally haven't. I was just looking at how the original worked, because obviously
So you're not like directly programming onto the graphics card.
No, I haven't done it, but the difference between doing it on the CPU and the graphics card is because the GPU is a GPU, and it does 16-bit float point values and not like 32. Effectively, you just cut the precision in half, but because a GPU has like 16 to 128 cores, you just parallelize it and you take every section of the image and assign it to one processor on the GPU.
And it can like have
So it's so
hundreds of,
fast.
like simultaneous processing.
Yes, exactly.
So you're cutting the time it takes by like 100%.
Oh
What
yeah.
time?
Hmm?
You spell vacation run.
I did. And I was like, well, I'm getting one of these times. It's actually right here, so
Same way you spell.
come on, wait, there. God damn it. Come on, go. Yeah, it works. Okay, cool. So I spelled it right that time, but there we go. You'll see that it takes a hot minute to do. So that took roughly 3 seconds on a still image to find this guy's hand. That's a really long fucking time. And if you're trying to wait 3 seconds for every single image you process and you're using a camera that's 60 FPS, you're no longer counting how many times you can identify a second, you're now counting how many times you can do it in a minute. So that's why when you're doing stuff like image processing, they require stuff like NVIDIA cards because their Turing architecture is basically, instead of doing all these loops and whatnot and the Fourier transform on the CPU, they have hardware that it just passes through and it comes out instantly. Let's see, what else did I have? But do you guys understand the general idea so far of how image identification works from the very horribly spewed out words I've just said? Good. I wish I had a more proper slide to show you guys all of this. I was trying to find my final presentation, which does a far better job of explaining all of this than I can right now. What? Is this my? Oh, hey, cool. So this is one of the presentations I was doing. But this is a presentation kind of on a bit of both. So
This one I haven't heard
the Hawks transform?
of. Yeah.
Hawks transform is a really cool concept. So
Just take anything and transform it into a hawk.
that would be cool. The mathematic explanation of how can we turn everything into a hawk. But no, this is basically going over transforming, finding lines. So obviously a good thing to do when identifying objects is to find where a line is, finding circles, and building objects around it. So one of the ways that we identify humans is we find the lines and the circles of a human. Obviously, we have a big freaking circle right here, and we have very stick-like arms, and so it's very easy to draw lines on us. Unfortunately, my program is not that advanced, but this is the underlying programming of how that works. So the first thing that which image am I on? Okay, this one. So the Hochstein form, again, method to find lines and ellipses. Ellipses are circles, ovals, that kind of thing. And it only works, or this version of Hoch's transform only works on a one-dimensional, two-dimensional array. 2D array, one layer.
To R theta? Is that what it's saying there? 2D coordinate plane.
Yes, yeah. So that's in the terms of the ellipse. In the ellipse, it's actually kind of stupid, and I'll show you in a minute. But I'll show you in a second. But so step one, again, we're going to take the Professor Neil Levine from electrical engineering, and we're going to bake him. Significantly baked. Next, we're going to apply a filter to the image. The best filter for finding lines and circles is the bilateral filter. I didn't use it because it is a very complex filter, and I did not have enough time to implement it into my program. But effectively, the filter now looks like this. Notice we got a pretty good outline of the items in this image. We got some pretty good, oh wow, you guys really cannot see that. We got some pretty good lines. So notice that we have a line here where the professor is sitting on, so the bench. You can kind of see the outline of it right here. You also have the horizon of the lake, the sky and the land. So this filter is the edge detection filter, and as it states, it detects edges. You can have the edge detection detect horizontal or vertically, or in any degree angle that you desire if you already know what angle you think the line is going to be at. This is a general edge detection, so anywhere that it thinks there's an edge, so if one side of the pixel is darker than the other, it'll draw the outline. I really wish I could show that brighter. That looks so much better on my computer. But here's a better attempt at trying to show you what the edge looks like. It also kind of shows the edges on his jeans, which is really cool. We're going to move it from, we're going to then, what?
What's that?
Oh, this is the Danish Museum's artwork. This is the, I don't remember what the name of the image name is, but effectively we are going to be, this is a second example of it. We're going to be going through and we're going to be mapping every single one of these white dots to another white dot. And so in line detection, in circular detection or ellipse detection, it's really freaking stupid. So how do you guys think it works just by looking at that image?
Edge detection, like we were talking?
Line detection.
Or line detection?
Yeah.
Is that the answer?
It's really stupidly simple. What it does is it takes every single white point, that is the wrong image, but close enough, and it finds another white point, and it just draws a line.
Okay.
And it does this for every single white point in this image. Yeah. So you're effectively going to be running
Very expensive.
a very expensive loop, hundreds on hundreds on hundreds of times. And effectively, to find a line, we just find a line where it hits 3 points.
What? That's it?
Yeah. So once the program is done finding all the lines, it's going to look like this. Obviously, a lot of lines. We then take every single line and then we put it through the Fourier transform, and where we have a significant amount of dots, or rather lines that are at the same angle, we have a good idea of where the line could be. So we have a match here and a match here. So we can identify that at, let's say, that's about 1.5. So about 45 degrees, we have, well, that's not 45 degrees, 90 degrees. At around 90 degrees, we will have a line. And I forgot what rho is because I'm a very smart person and I don't.
Rho is the 3-dimensional. So usually it's just r and theta.
Yeah.
For polar.
It's the distance. It's the distance from the center.
Yeah. What's interesting is this rho. So rho only shows up when you do a 3-dimensional sphere.
Yes.
And you're mapping something to a 3D spherical space.
Yeah.
Which is interesting because it's supposed to be a 2D circle. But
Yeah. No, the thing is that when we're drawing the lines, it's still in a polar space. So if I go back to here, imagine that. Yeah.
it's gonna be hard to imagine.
Yeah,
It's just a big red square.
Imagine that my arm is the line. It knows what angle it's going to be at, and then the rho basically tells you how far away from this corner it is. We're just doing where the line is. We're not exactly pointing like, oh, the line is between here and here, right? We're just saying where a line is going to be on the image. Image like detection in computer science is super simple, and it's nowhere even remotely complex as anyone thinks it is.
Just expensive.
It's horribly expensive, yeah. This is the algorithm for it. Don't worry about it. But either way, the downside to sampling 1,000 points at a time is that sometimes you get an error like this, where we had a point here, and a point here, and it makes a line that is clearly not correct. But the upside to this is that, or actually there is no upside to this. We effectively do it again, but instead of doing accumulation, we do, what do my notes say? Oh yeah, there's no fixes to this. So there's no fixes to this. The only way we can do is that we can add more logic. This logic, I don't remember because it's been way too long since I've given this presentation, but effectively, I think what I did this time is that I also ran through a Fourier transform because this is infinity to negative infinity again, and effectively we have a white spot. White spot is where we're most likely going to have a line.
That's the end of the slideshow.
And what in the world?
That's as far as you got.
Yeah, apparently. Where did my actual slideshow go? Either way, that line actually corresponds to this line here.
Can you go back to the heat map?
Yeah. Obviously, I am telling the complete truth and nothing but the truth, and that you guys can clearly see that I'm not lying about any of this. But anyways, heat map.
That is a 3-dimensional graph, right? Because you have x, y, and you also
Yes.
have heat at x, y.
Technically, yes, it is 3-dimensional in a sense.
Really?
But it's more 2-dimensional, but with higher values. This goes from 0 to 350 for every single index array, or not every single index of the, yeah. So for every index in the array, it can go from 0 to 350. So it's really just a 2 by 2. The only difference between this and
Isn't the heat a third variable? Then B or Z, yeah?
no, it's just the value.
That is a axis.
Make it height, then you have a 3D image.
Yeah.
Well, I guess it is, yeah. Well,
Yeah.
I'm thinking that like how we store it, not necessarily of. Yeah, I guess it is. It would be. I'm thinking of it in a different sense, but where's the proper
Actually, a better
image?
Summary of Hawks, because that's interesting.
Yeah.
Because you have a 2D image.
Mhm.
It is a 2-dimensional, well, I guess 3-dimensional array of pixels.
Mhm.
But effectively, you have. That's why it's rho, because it is 3D.
Yeah.
But that gets converted to the polar coordinates, which is what
You good?
Fourier works off of,
Yeah.
which
Cool.
is interesting.
Yeah. So it's
So at the end of it, you end up with a frequency distribution.
effectively, yeah. So that's what that heat map was.
Yeah.
This is another version of the same project. Let's see if they are able to answer it better than I can. They use the exact same process. They used a different line detection software, or not software, but method. This version of their line detection is Still a Hawk's transform. Interesting. But in their version, you can clearly see where the heat spots are, and it actually detects where the lines are. As proof that the hot spots would actually produce lines, that's it. But any questions in general about image detection and line detection or anything like that? What's up?
Has 3 blue, 1 brown done a video on Hawk's?
Oh, probably. He's done so many mathematics animations that I have no doubt in my mind that he's done one.
How much time do we have left in our
Meeting. We have about 10 minutes-ish. This was how we do with the ellipse. Instead of finding all the lines, we just find all the circles, and wherever we find three dots, we base the 3 dots.
Why is it 3
That's
dots?
the edges of the image. Well, I put it to 3 because if I had it find more than 3, it's going to take forever.
You have less lines.
Yeah, well, well, you have to do it and match perfectly.
Can you choose how many dots line up?
Actually, yeah, you can. Now that I think about it, I could have just not had it done, because technically we're just finding all of the ellipses and then checking which ellipses match. So it's rho theta. Yeah, no, I could definitely add more points. Yeah, because I put max as 4 here. I could definitely increase it to 5.
So would that just
Yeah.
like increase how picky it is about?
Yeah, exactly. So it would basically just be adding more data points that I need to check before identifying that something is a line or a circle.
You'd end up with less circles at the end though, or less confirmations, less hits.
Yes. So it hypothetically be more balanced. Did you already sign in? All right, perfect. But
Bye.
later. Good luck catching the bus. Let's see if I can find the end of that real quick so I can prove, just for my own sanity, that it does work. Because I would like to prove that. Why do I have so many copies of the same homework? Oh yeah, so you guys can't see that. Again, when we're trying to find all of the circles, it is literally just splaining circles all across the image.
Trying all possible circles.
Exactly. And then these are the 3 that had the exact same distance across, so the same radius. We found where the center of these 3 radiuses, which is right there. Take the radius from that center point and then plot the same area, and that's the moon. This program finds the moon effectively every single time. I love that. Only when it's a pure night sky. I found if I added trees, it starts circling trees for some reason, because apparently trees are circular objects to this program. And this is the same exact code from before, and as you can see, it doesn't do it very well, but it does find the line on the bench. I think it was taking it from here, and then bench moved. I'm gonna say it's the bench's fault, not mine. But yeah, no, it's image detection, object detection. It's really cool. Either way, I'm gonna ask everyone, if they haven't already, to go ahead, scan this, and sign in. It's mostly just because food is super expensive, and whenever I go ask for my money back, they always want to say, all right, so who is eating the food? And I have to show them an official report and the QR code they accept for some reason, so that's that. So we have 10-ish more minutes. Anyone want to build paper airplanes and see who can throw it the farthest? Let's do this.
I'll destroy you guys.
You destroy the civil engineer bound to destroy this. Let's do this.
An actual engineer, mechanical engineer.
Mechanical, Mike.
The real work.
The real engineer. Alright, everyone want to come up and grab some paper? Come on, Omar, I'm not gonna make. I'm not gonna. You're sure?
I'll be the first one up.
Just like, I am the better engineer. Come get my paper for me. All right, let's build some paper airplanes.
What's the goal?
I would say basically we're going to start from up here. Let's actually start from over here so we're not blinding people. Just try to throw it as far as possible. Window obviously is a pretty good target.
Distance then?
Yes. My bad. Yes, distance.
Watch there for the record.
Want to participate, Drew?
All you guys?
Yeah, well, so,
Just gonna sign in and get signatures.
but do you have any other questions about machine learning?
I didn't realize that the Fourier transform was involved in it. I would be curious to see how many of everybody else is familiar with the Fourier transform.
It's not that, like, familiar of a concept, really, unless you're doing, you don't realize how important it is until you look at the, like, the underlying technology of anything, and you
Yeah, it's
realize it is
everywhere.
everywhere.
Especially the FFT is everywhere in music production.
Oh, yeah, because, like, you know.
That was the
waves,
first context.
airwaves, yeah.
Well, that's, if you've ever seen frequency, what is it? Like a frequency display?
Yeah.
Frequency, a bandwidth, or a band, why am I spacing on this right now?
I know what you're
But yeah, what it's literally doing is it's sampling the music, and as it gets its sample, runs it through the Fourier transform, turns it from amplitude over time into amplitude frequency. I said time earlier, it's
Yeah.
amplitude frequency.
Okay, so I was,
No, I was wrong,
Yeah.
yeah.
I
What's
really.
interesting in music is it ranges from negative infinity to, I think, well, technically you can do plus, but
Yeah.
it's negative infinity to 0.
So what they usually do is they transform it, because again, I misspoke it earlier, it actually goes from 1 to negative imaginary 1. Obviously, mathematics
It's kinda
can't.
strange.
Yeah,
Yeah.
it can't represent that. So in some programs, because we can use float point values, we say the float point, it goes towards infinity instead of imaginary. And so that keeps it, we basically bind it, or we move the bounds from imaginary to the infinity.
My understanding is that imaginary is movement in the third dimension, when you're restricted
Yes.
to the second dimension.
So going with time, because we're actually, what we're doing is
The sine and cosine waves are actually a corkscrew.
yeah.
Yeah.
So what it actually is doing is that what the actual function is doing is taking a derivative, and we're doing it in a matrix multiple, or in a matrix
So
idea.
it's like all of the worst parts of math that everybody's afraid
Yeah.
of all tied into one.
And obviously doing a derivative is quite long, it's quite expensive, and so that's why we do the Fourier transform. Watch out. Wow, that did better than what I thought.
There's
Yeah.
that big point, that little
Yeah.
square right there?
Yeah, so front foot on the square, because that's a part that's not gonna move.
Let me make a second.
Let's have everyone move over here. So I don't poke anyone's eye out and we don't have to file insurance forms. Oh no! Hey, if you want to go again, go for it. Let's say 3 throws for everyone to make it fair.
Oh, that was good.
Very nice. So that people online can participate, we're gonna aim for the camera and give them a little jump scare. If you hit the camera, I'll be happy, but do not. Event services that I said that. Where did yours land?
Very close to me.
Where you wanna go again? Oh wait, who's that?
That was mine.
Yeah, you did really well.
Oh, I beat you.
In hindsight, I should have set the camera before throwing the plane. But, all right, so we have, where did yours end up?
Oh, I tossed mine.
Oh,
It's
okay.
crashed.
All right, so we have one end up right here.
That's a good design.
Try one more time.
There's one end up right here. Omar is like taking his incredibly.
This is my second one, actually. This is the aesthetic one, right?
Let's just say if you pick up, you nullify that throw. Here, stand on the square. Go for
This is double.
it. Nice.
Okay.
Very good. Hello? Where's the second slide? The slide doesn't pop up on here? That's dumb. Can I just download this?
I'm gonna get yelled at later because I was told to have everyone name the paper airplanes. Oh well, it happened. Should I just download this?
I was gonna write copyright mine.
You said you're gonna copyright yours?
Yeah, I was gonna write I guess I was gonna write, yeah.
Oh.
Make it my intellectual property.
Take down the channel because we showcase you.
Yeah.
Dude, I'm so worried because Mosh, don't get me wrong, I love Mosh. Mosh is a very, very nice person. And he'll do a lot. If you ask him to do something, he'll get it done. But he keeps playing music and videos during the meetings, and I'm afraid that YouTube's going to copyright strike one of those one day. And all my work of getting the channel up and getting like an online presence is going to get destroyed. Go ahead for it, Omar.
Alright, this is my actual competition one here.
Okay, okay. Let's see what the mechanical engineer can do. Can he build commercial airplanes?
This is a bomb. It's a missile.
It's very thin.
This is an ICBM.
It's basically an arrow.
Yeah, so there's no resistance. You just make a little ball and just toss the ball. So it's not about the plane.
Oh, damn. Smooth. You gonna go again?
That's the one where you the stronger you throw it, the further it goes, rather than any propulsion. It
It's
doesn't.
effectively a missile.
Yeah, it's just a missile. It is just a missile.
Okay.
Try the hamburger one. So you go longer and you just make your basically what he did.
So basically, he's working for Raytheon right now.
Yeah. Yeah.
I mean, you getting good.
Let's see how this one's like. This is my favorite.
I tried.
Good. Okay.
Worst one so far.
I mean, you heard.
We're betrayed.
All right, so hold on.
Oh!
Before we throw any more, just to make the other officers happy and so I don't get beat up later, name the name of the plane before you throw it. All right, what name are you giving it?
Let's see.
Tesla, let's go! Nice. You might want to put your glasses on. For safety measures. But yeah, that's all we had for the day. Thank you everyone for coming out. My name is Aaron. I'm the treasurer of the club. We do need more officers because I need help. Also, I'm not going to be here next semester because I'm graduating. So if any of you guys are interested in that, let me know. We also are going to be holding votes soon.
This might not be the most original thing, but I
Yeah.
just thought of another activity.
Okay.
Remember the AI generation competition?
Yeah, which very few people entered.
It was not well communicated.
I tried. It's okay. Oh, I should send an email. That would be
Yeah.
better. Oh well. Oh!
It flew far.
It flew in a very smooth path too. Anyways, your
Yeah,
idea?
I don't know how to translate at all.
Somebody generates the images and you guys the prompts.
Ooh. I like. Well, the problem is people don't do very complex prompts, so it probably.
Well, it's in charge. Whoever's in charge of the.
Oh, I'd have to make a pretty complex prompt.
You make
about
a
it.
gallery.
I'll make a
and
chat
images.
GPT. I'll make chat GPT make a very gallery in the
Yeah, or whatever their drawing thing is.
Yeah, you're welcome. Go around. What's their name again?
They're
Lisa?
Abby.
Allie?
Allie.
Go for it. 10 points. Oh, so what was your name? Oh, sorry, what was your name? Win?
Yeah.
What's yours? JC? Okay. Any of you guys Alejandro on Discord?
I know Alejandro. You didn't show up today.
Okay, they texted me asking if there was going to be food. I'm like, yes. For once there will be.
And now the show.
No. I even spent time to make sure we had food. No, I'm trying to get pizza, but like every time I go to Pizza Hut, there's just a super long line, and it takes 20 minutes to fill out this form, and I'm like, I don't want to spend 20 minutes of other people's time in line filling out forms because I have to hog up the front of the line. Nice, very nice. Of course, I'm always recording, Drew. You know that.
Let me throw a little gap. It's kind of funny.
Come on.
I just asked for it. What was it again? When? No, year when? JC. Okay. I will get people's names.
It's my first name.
What's your last name?
Oh, H-O.
Oh. Wait, so you have the prince's name first, not the last?
That one is different. I
Oh,
was
is
born in Vietnam, not here.
Okay,
Yeah.
interesting.
The what?
So, Klein.
Win.
You win? Okay. So, there's a prince in Vietnam, pronounced, you might pronounce it for me. Is it Nguyen?
Yeah.
Wait.
Nguyen. Yeah, the NGA, or
NGUY.
the horribly butchered English
Yeah, we don't do a good
translation.
job. I'm sorry.
Yeah, but the reason why you find a lot of people with that last name is because a lot of people, you know how a lot of people in Britain want to be like part of the royal family, and they'll like say, I have a claim to the royal family. It's something, it's not exactly the same.
How good is he doing? Is he doing okay explaining this?
Yeah.
Yeah, he's doing good.
It's a
I
little
assume
bit.
you're the actual expert on this.
Yeah, exactly.
We should probably be deferring to you.
That is the last dynasty in my country.
Yeah.
It's when the West about to take the whole country play.
I don't know how Terrence lives. Like,
Okay, so
yeah.
the
sometimes it
last
does,
like
sometimes it doesn't.
major royal
Yeah.
family of sorts.
Yeah.
I see.
That's fine.
Yeah. So it's basically like a tracking thing, but yeah.
It's like kind of paying respects kind of a thing, or not really? Is it like a paying respects kind of a thing?
Yeah.
Okay.
But yeah, it's kind of cool to think about.
All right. That
That one's gonna hurt someone.
How does that go over so well here? It's like random people like naming themselves like Obama or something.
All right. I'm going. I'm gonna name you the Obama. Go for it. Fly.
Wow, that crashed hard. No, you did not do the planes way up there. It's up.
All right, let's clean up because I have to go to class.
You have class?
Yeah, I have class right after this. It's great.
That late.
Well, I mean, my first semester here at Sac State after I transferred, Drew and I had a class at 7 o'clock. That was great. I passed out, I think, 3 times in that class because it was so late at night. Like, every single time I came to class, the sun was going down, like, my brain doesn't like this. It just passes out. It was not great.
Wasn't that remote at first?
What? Yeah.
First couple weeks it was, yeah. I remember that because there was like nowhere to sit, so I was like out in front of the library freezing my ass off. On
Yeah.
Zoom, you know.
Have a good one, guys. Yeah, Asian history. Fun times. 1 box left. How much do you want me to guess the veggie box?
It's gonna be the veggie box.
Yeah.
The veggie stuff's okay. I'm just eating it because it's free food.
It's good. Well, we had a lot of Indian people for a hot minute. So that's why it's a veggie box, because, you know, they can't necessarily have turkey.
Right.
And unfortunately, what's her name? Victoria can't eat any of this because she's allergic to the bread.
Oh, gluten, yeah.
No, she's not allergic to gluten. They add vinegar to the bread. Subway bread, because the way they distinguish it, they use vinegar instead on their breads. And she can't have the vinegar that Subway uses. Yeah. So she's by default allergic to all things Subway. She can have pizza, but as I mentioned earlier, getting pizza is a nightmare here. Because, I don't know if you've ever tried going to Pizza Hut, but,
What about the round table on campus?
sorry, not Pizza Hut, Round Table.
Oh, okay.
Yeah. Have you tried
You
getting
can't-
pizza there before?
You can't cater outside of the school, can you?
Not easily.
Do Shando's tacos.
Which ones?
Shando's tacos.
Oh, fuck no. Everything is super expensive. It's really annoying. Subway's
Yeah,
the
I
only
don't
thing.
think, like, or are you talking about just in general, or like
In
Shando's
general,
specifically?
but
Because
like-
Shando specifically is very expensive.
Yeah. Well, it's cheap, but the proportions are super small.
Yeah.
They're non-existent. But the thing is, like, Subway is the only vendor on campus where they'll provide a bulk deal. So all of these is $50 for one of these. Individually, each one of these would be $6.
It'd be a nightmare to try to do it with like Panda.
Yeah, no. I have to buy one serving every single time.
Right.
No. I'm buying 2 of these
and that makes my life a whole lot simpler.
What about tokens?
Same thing, no bulk deal. It's like this is the form I have to fill out. One line for Subway. I did anywhere else, every single line.
So is it just like filling that out, or like how do you get
So-
reimbursed by the school, or?
So the way that reimbursements work for you can order a future, which is less likely to be reimbursed, or you can do a reimbursement of a past event. And so effectively, since today is the 2nd, this is now valid, so long as everyone actually signed in. I can go in, I can show them the amount of money that I spent on this meeting. I can show them the receipt that people actually showed up, which is also why we have the live stream. So I'm like, oh yeah, look, all these people showed up. And then I can get the amount of money on here back. Which is also kind of cool, is that they don't deduct, like if your card skims off it, so you don't get 5% back, they don't count that.
So you can do
So I have-
5%.
Yeah, exactly. I
Okay.
skim off 5% every single time I buy
You do?
it.
Where are you flying to?
Yeah, exactly. The Philippines, hopefully. I just got my passport yesterday. It's really nice.
Is that to visit family, or is that?
Just to travel with my mom, because my mom has family all across the world, and so hopefully visit them. I need to learn Tagalog again, because I forgot it. But yeah, no, it's honestly the process, once you do it 1 or 2 times, not that hard. But like, doing it the first time, needlessly complex.
Just to set up the passport and stuff like that?
Oh, no, for this stuff.
Oh, I'm
Yeah.
sorry, talking about traveling. Yeah.
The passport was actually way simpler than I thought it was going to be. It just took a long time because it's a passport office. Also, there's a passport card now. Yeah, so if you're traveling anywhere in North America, you can just get a federal ID.
Oh, yeah. I heard about that.
It's really nice. So I keep the federal ID on me, and then obviously the passport stays at home. You ever travel anywhere good?
Yeah, well, I went to Mexico once, and I went to Canada on a cruise.
Nice.
I haven't gone to Europe at all, and I haven't gone to Asia or Africa, so only the continental U.S. basically.
The downside of going to continents like Asia and Africa, especially when you're older, is that they have different viruses in those countries.
Oh, so you'll get sick.
Yeah, you have a much higher chance of getting sick and potentially dying from that sickness. I mean, granted, if you prepare ahead, you tell your doctor that you're going there, they can inoculate you, inoculate you.
That's smart, actually. I didn't think about that.
But if you don't do that, and then you drink the water in any of those other continents, you're dead for 2 days.
Yeah, Montezuma's revenge happened to us in Mexico.
Really?
Or at least my sister and my mom. Unfortunately, they were
During an accident?
They were chilling in the apartment, or not the apartment, the hotel for a bit. A couple days there.
Did they end up sitting on the toilet for most of the time, or did they just pass
Basically,
out?
yeah, they switched off of the porcelain throne.
I came prepared with this iPad. I was planning to like draw out like the whole sketch of it, and I just didn't get to it.
Seems like there's a couple hang-ups and technical difficulties
Yeah.
there, which is sad because it seemed like you put a lot of thought into it.
Yeah, no, this is like in data science. I'm more interested. Like everyone else is like the generation and crap and all that. I'm more into the identification and line detecting because that's the stuff I want to do because I'm trying to make an automated streaming AI. So that's more towards what I want. But like most of the stuff that can come to.
Was Mosley here at one point?
Yeah, he came in a little before you, and then he went to go to an office hour.
Oh. Well, his backpack's still here.
And he's coming back. Mosh always does. I'm not going to be too worried about it. If Mosh forgets his stuff and he calls me, I'm just going to tell him to go to event services and they'll deal with it. And honestly, if he locked the door, it's probably going to save us for his backpack. Actually, I think I hear him coming. He has a very distinct jingle to himself.
Anyways, I'm gonna get going. So.
Bye,
Good
Drew.
evening. See ya.
Thank you. Have a good one. Did you want any veggie sandwiches before you head out?
I'll be okay.
Okay. Have a good one. All right, well, seeing as I'm here just talking to myself.
Drew.
Told ya. Hey, Mosh.
Sorry I'm late.
No, you're good. You
What
want to have
happened?
veggie sandwiches?
Yeah, sure.
All right,
Oh, man,
grab
it's
a few
almost-
before I head out. How you doing, Mosh?
Good. I know it took a bit longer. I know. I already finished it, the lab, but now I have an issue where I export the PDF, the text moves. The text that tells which photo it is.
That happens all the time.
Oh my goodness.
Honestly, you just gotta just screw it. Can you export it? What program are you using?
I'm using Google Docs.
Oh, you can you're exporting it as a
PDF.
Word doc.
Okay.
Or export it as a Word doc and then in Word do the alignment.
Okay.
It doesn't work all the time. It still has a pretty good chance of moving. But you know, you'll have a chance of actually printing it out as you want to print it out.
Okay.
All right, let's close down the live stream. And Mosh, turn around to the camera. Bye-bye.
Bye-bye. Bye. Hope
We
to
should
see you
stop.
next Thursday.
We should have, I want to get back into doing that. That's a fun thing to do.
Yep. You didn't have much to do?
Oh, no, we had plenty to do. So what we did first was,